In this video we shall continue discussing relationships, and we shall see how to create a relationship using some special tool or tools in our case. Let's start with one-to-many identifying relationship. We shall use association tool. We shall click here, hold the mouse and drag it to parent relation. Release the mouse and we shall adjust fields. With parent relation, EID is good, it's primary key, but with child relation we have to select the foreign key, P person. Okay? Here it is. But this relationship is not yet identifying. In order to make it identifying, we shall also switch to columns and make it the part of primary key. Here it is. The next approach is not making it a part of primary key, but leaving it not nullable. While it not nullable, we cannot put null values in it, so we can not make a record in payment table not related to a record in employee table. And that's why our relationship is identifying. The next example is one-to-many non-identifying. We shall also use association tool, make the same action. Here it's OK. Here we shall select C room. OK. And that's really all. Let's make sure this relationship is not identifying. We shall open features columns and we'll see that this field is not a part of primary key and has no not null property selected on it. So we can easily put null values in this C room foreign key, making a computer a free one, not belonging to any room. The next is many-to-many relationship. Here we have to create the association relation. Let's name it, for instance, M2M, student, subject. OK. Then we have to add two fields here, or maybe some more if we need. We shall switch to columns, add STID for students, SBID for subject, and let's add the mark here. Then we have to adjust data types. Okay, here we can see, what can we see here? Let's check. Features, columns, STID is auto-incremented, unsigned. That's okay. Let's check from this side, subject, columns, SBID. Let's make it also auto-increment, unsigned. Then we shall return to this table. Open it, features, columns, and make this field integer. We cannot make it auto-increment here, it's impossible, but we have to make it unsigned. The next field, also integer, never auto-increment here, but also unsigned. Mark should be maybe integer or maybe something not so huge, like tinyInt. Usually we have to make these fields parts of primary key. Let's do it and explain why do we need it. Because that many-to-many relationship that not yet exists shows that a student learns some subject. And a student learns a subject only once, it's a fact. So we may not say that some John Smith learns mathematics for 1,000 times. It's illogical. So those combinations should be unique. In some other cases, for instance, if we have to show several marks for several attempts of a student to pass an exam on a subject, we shall not put that fields in primary key. But usually, in most cases, those fields should be parts of primary key. And the only thing left is to create the association. Let's make it 1, STID, STID, that's good, and 2, SBID, SBID, that's good. Here it is. That's the result. We have many-to-many relationship. And the only thing left is one-to-one relationship. The first approach is to use primary key. So we shall use this association tool, connect our relations, and we see with parent relation the primary key, with child relation we shall select its primary key also. Here it is, here is the result. We may easily see that that field is PFK, primary foreign key. That's good, that's one-to-one relationship. But we may use another approach. Imagine for some reason we do not want or we cannot make the foreign key the primary one. So we may add some field here, like for instance PT owner. Let's check our data types. It's integer, not unsigned, so we shall use int. Here it is. We shall create the association pn id, here pt owner. Okay. And how can we prohibit duplications on that field? We may create a unique constraint. So we open features, constraints, and add in something like unq owner. We shall select type unique and add that PT owner field here with double click. We may now close that dialog window, and that's the result. That's all. Here we have one-to-one relationship with unique foreign key. Here is our unique foreign key. We may now export the result into SQL query. Let's click develop, generate, select something like export SQL, click generate. We may now open this SQL file for some quick review in any text editor. And let us import this database structure into DBMS, fill it with data and show some examples of SQL queries on it. Let's not waste our time on those long processes of exporting, importing, filling with data. Here is some result. We can see the contents of employee table. You can easily check that it has the same data as in video of some couple minutes ago. And the contents of payment table. And imagine we wanna know the sum of money for each employee. Our course is not dedicated to SQL, so here will be no detailed explanation, but the main idea is we select employee name and the sum of money. Employee name we get from employee table, money we get from payment table. We are joining the tables on primary key equals to foreign key and grouping the results by employee ID. And once we execute the query, we have that result. So that's how we can access some data that stored in separate tables. The next example is about rooms and computers. Here are our rooms, here are our computers, and imagine we have to get a list of rooms, each room, even empty room, and we have to get a list of computers inside each room. So we select room name, group of computers names or descriptions. Room name we get from room table. Information about computers we get from computer table. We have to use left outer join here in order to preserve empty rooms in the final data set. And we join in the tables on primary key equals foreign key and grouping by the identifier of room. And once we execute the query, here is the result. Here it is. We see a room, a list of computers, a room, a list of computers, a room empty, and another room also empty. And the last example with 3 tables. We have students, here they are. we have subjects, here they are, and we have that association relation with student ID and subject ID and some marks here. We want to get a list of subjects, so we have to select subject name. We want to count how many students are studying that subject, so we count this field. We have to know the max mark for a subject, and we have to know a list of students studying that subject. So everything about subjects we select from this table, everything about that interconnection we select from this table, and anything about students we select from student table. And once we execute the query, here is the result. If you want to know how to create such SQL queries yourself, you have to refer to some SQL Basics learning course. And in the next video we shall continue discussing relationships, and we shall talk about referential integrity and cascade operations.